Just before we get started, I wanted to thank you all for being here, and I'm very happy to be able to introduce our lunch panel. What we're going to do is each one of them is going to take about 15 minutes and talk to you about what they've prepared today, and then at the end of that, we will take questions from the group with the time that we have remaining. So to begin with, I would like to introduce Dr. Beth Catlett. She is an associate professor and chair of the Department of Women's and Gender Studies. She also is the co-founder and director of the Beck Research Initiative for Women, Gender, and Community. The Beck Research Initiative promotes community-based programs and research that inform the prevention of and intervention in gender-related oppressions. DePaul University faculty and students work with community members to effect social change through social policy, advocacy, and community development. This work seeks to create mutually reinforcing synergies among classroom learning, social science research, and community engagement. Beth's scholarly areas of expertise include interpersonal relationship violence, men and masculinities, teen dating violence prevention, student learning in community-based service learning contexts, and community-based participatory research models. In addition to teaching a variety of courses in the Liberal Studies program and in Women's and Gender Studies, Beth has developed a strong teaching portfolio in community-based and experiential learning. She also is committed to integrating community-based research projects into course curricula. Teaching in these contexts has informed Beth's teaching philosophy in substantial ways. Please give a hand of applause.
It really is delightful, as I'm sure many of you in this room know. As a department chair, I spend way too little time now thinking about teaching and really immersing myself in teaching, so it's really, really delightful to be here. So thanks so much. So as you heard from the introduction, I really do have a varied teaching portfolio, and at the risk of creating too much of a dichotomy, I think for our purposes today, it's really interesting to think about that I teach a whole range of sort of more traditional academic classes, classes like I teach research methods at both the undergraduate and graduate level. I teach a class entitled Gender and Families. I teach a class entitled Women in Violence, etc. And then I also teach classes that are more experiential learning and community-based service learning classes. And some of my pedagogical commitments, I would say, really span all of these different classroom contexts. And then other philosophies, strategies, etc., I might tailor more specifically to particular contexts. But I think today I'll really talk quite broadly about, of course, the topic of the day, promoting critical and creative thinking. And I think as an initial matter, I want to situate myself and lay out some of the assumptions that I bring into the classroom as an initial matter. So number one, I would say that my classrooms are never very hierarchically structured, right? I do not ever set myself up as the expert imparting knowledge that the students should just receive. But really in every environment, whether it's 12 students or 40 students, I at least attempt to say, we are in here together as a community of learners, a community of scholars, where we sort of create a reciprocal process whereby we are learning and teaching together. Right? And I say this probably every quarter, and I firmly believe it, that students have more to learn from each other than they have to learn from me. So I see myself as a facilitator in a lot of ways. I think the second thing that I always try to bring to a classroom is this idea that we're not really here to answer that many questions. What we're here to do is continue to raise new and more multiply layered questions. And sometimes this really is a disorienting or what I call a sort of destabilizing experience for students because oftentimes they want answers, right? And so in research methods in particular, I am teaching about feminist-informed research methodologies and methods. I really talk to the students about this is not going to be a how-to class in any way. What we're going to do is continue to complicate issues around the navigation that feminist scholars need to continuously engage in. How do we navigate the dilemmas of what it means to do research that is ethically sound, that will promote social justice, etc. So really raising new questions instead of posing certain answers is very important for me, right? So I know we were asked to talk about a couple specific strategies and assignments, so I do want to get to that. I think one thing I want to convey today is that I am always talking about, in different classes, the socially constructed nature of knowledge, right? So I start many classroom experiences really beginning to explore with students the ways in which all knowledge is partial and particularly situated. This was not my original idea. I borrow a lot of these ideas from Donna Haraway, among other scholars. And so, in particular, in one class, in my gender and families class, we start off and I say, we will not use the word fact in this class, but rather what we will do is use data and use evidence to think through complicated issues, right? So this real focus on not fact and all knowledge is particularly situated is really very important in my classrooms, and I think for the promotion of critical thinking. So one of the papers that I have assigned in a variety of different classes we often call the Who Am I paper. And I am asking students, I nauseate them with, sort of again and again and again throughout the quarter, talking about the need for them to locate themselves in their work, right? And so a little bit drawing upon you're talking about centering students' learning in their own experiences or not. What I'm asking students to do in that assignment is to both center their learning in their own experience, but then also decenter from that experience. Because what I'm asking them to do in the Who Am I paper is to say, here's who I am, here's how I'm particularly situated in systems of privilege and oppression. So here's who I am as a gendered person, here's who I am in a racially stratified world, in a world that's organized around social class inequalities, sexual inequalities, etc. Here's who I am, and here's how here's how I'm going to begin to interrogate how this shapes my experience of engagement with different knowledges, right? So that's one assignment that students, I think, find both destabilizing and disorienting, but also very helpful. And this is an assignment I often give at the beginning of a quarter, right? And so it's really asking students to think about themselves, and then throughout the quarter, they begin to really understand who they are, how they're located, and how that might have shaped assumptions that they bring to their work, right? And I'm happy to share more particulars about these assignments if people are interested. I think the other thing that's very important in terms of promoting critical thinking among students is looking at complex issues from multiple perspectives, as I think you've already heard here this morning. So I thought I'd talk a little bit about one of my classes. In the Gender and Families class I teach, this is a class that's cross-listed crazily, right? So it's undergraduate sociology students, undergraduate women's and gender studies students, graduate sociology students, graduate women's and gender studies students, graduate students from other programs. So it's really got multiple audiences. Many of my colleagues complain about how difficult it is to teach to multiple audiences, and it is. It's a challenge, but I frankly find it a blast. And in this class, one of the ways that I really ask students to engage knowledge critically is through one of my, I don't know if I should say favorite topics, a topic about which I have written and care, is the marriage promotion movement as part of welfare reform. And so I don't know if people are or how familiar you might be with this, but it's basically the idea that we take in this country a good chunk of welfare, public aid, budget, and promote marriage among heterosexual individuals, because the idea is that if you're going to get married, it will lift you out of poverty, right? And my students know how I feel about this policy. You could probably guess how I feel about the policy, just the way I just said that, right? And I've written about this topic, and they read my article usually, but I really walk away from the way I feel about this policy. And we have readings on both sides of the issue, right? Those who would advocate strenuously for the marriage promotion policy agenda, and those who argue strenuously against it. Right, so we read on both sides of the issue, and then I assign an in-class debate. And what I ask students to do, it really is the honor system, but what I ask them to do is choose the side that you really think that you would argue against, and argue for that side in the debate. And part of the reason I love this topic is there really is solid, compelling data on both sides. And so the sort of subtext is to help students begin to think through really critically and creatively how it is that we use data, right, to support particular policy agendas. And I actually could argue probably pretty strenuously on both sides of the issue, even though I feel, right, and am committed to my position. I really like the way this issue lets us look at data and how data is used. So that's another assignment that I have found both very compelling for students in promoting critical thinking and also helping students see the complexity of issues, right? The other thing that I want to talk about is some of my teaching and learning experiences in a more experiential learning environment or a community-based service learning class. So I will tell you that one of the projects within the Beck Research Initiative that I have co-directed for the last 8 years is called Take Back the Halls, Ending Violence in Relationships and Schools. And in this project, we have DePaul undergraduate interns working in area high schools over the period of an academic year, facilitating with teen dating violence professionals. They facilitate what we call a violence prevention and community activism program. And what we do as part of this, their year-long experience out in the field, is they have a community-based service learning seminar that I teach, right? And I find this context really ideal for promoting critical thinking among students, because what we do throughout the entire quarter or quarters that we're studying together is really critically interrogate how do the ideas that we read about and we talk about in this classroom or in this ivory tower, how do they apply and translate in the real world, right? So for example, it's really easy for me to get all excited. I assign at least a couple chapters of Paulo Freire's book, Pedagogy of the Oppressed, right? So many people have heard of this work, right? And so I get really excited about this, and our women's and gender studies students in particular get really excited about this liberatory pedagogy, right? Letting our educational models emerge from the perspective of real life people, right? The oppressed, if you will. And then so we talk about this in the classroom, and this makes sense, and we're committed ideologically, right, to this standpoint. Then we talk about how really is this working in a classroom of adolescents, right? I don't know how many of you have worked with adolescents or had your own kids. Mine, thank goodness, are past adolescence. And what I always have said about that is just put on your seatbelt and enjoy the ride, right? So how well is this let what we do in an educational setting, let it emerge from the students in the classroom? Well, in a way, it really works quite well, but we're complicating the ideas. It doesn't exactly work as smoothly as one might think, right? By just sitting in our classroom and reading the book, right? And I do think the other thing that I've done really intentionally in the context of this community-based service learning environment is ask students, I think you called it, did you call it disorienting experiences? I tend to call it destabilizing experiences. So one of the things that we're asking students to do a lot is to look at their own privilege and privileges. So because very often we are bringing white upper middle class and middle class students into urban high schools that are low income high schools and predominantly students of color. Really asking them to interrogate their own privilege and think about how it affects their work with the students in these high schools. And this is always a destabilizing and an uncomfortable experience, but one that I have seen promote some of the deepest and richest learning experience among our students. So again, you know, with questions or if we can talk after, these are things that clearly I'm passionate about, and I think there's a lot of more specific things to be explored, but I think that interrogation of how a student translates knowledge that they're learning and examining and engaging in the classroom and looking at the ways in which it applies in the world is one of the most readily available ways of promoting critical thinking. So my time is up. I'm so delighted I stayed on time. Thank you very much. And now we'll move on to the next panelist.
Thank you, Beth. Our next panelist is Jesus Pando. He earned his PhD in theoretical astrophysics at the University of Arizona. He was awarded a Chateaubriand postdoctoral fellowship and an NSF International postdoctoral fellowship to continue his research at the Observatoire de Strasbourg in France. He joined DePaul University's physics department in 2000 and currently serves as chair of the department. He has mentored many undergraduates in research, has served as faculty advisor for student organizations that focus on access of traditionally underrepresented groups to science, and in 2012 he was awarded an Excellence in Teaching Award from DePaul. So please give him a hand.
Is this on? Is it? Okay, thank you. Good afternoon. I am also very excited and frankly nervous to be here. I'm not used to speaking to colleagues of these sort of varied interests and expertise. I wanted to share a little bit about what I think about how to encourage critical thinking in students by moving away from the idea of teaching and focusing instead on student learning. And that's a subtle, perhaps, distinction, and I hope that by the end of my 15 minutes I would have made that a little clearer. But first, let me say that as scholars, as scientists, I usually give this kind of presentation in front of scientists, but as scholars, I have found that we are the least scholarly about our own teaching. That is that because we've been successful in learning and getting to the situation where we've gotten to, typically it's faculty, that we think that because we were successful under whatever curriculum or whatever pedagogy we were exposed to, that's the pedagogy that we should then employ because it worked. And it did, because you are where you are. Clearly, that's not the case for many, many students. There is lots and lots of studies that show that, in fact, we are losing potentially successful students because the pedagogy is wrong. And I hope by the end, again, after these short remarks, that I would have made that a little clearer. The first thing I want to say is that, so my talk is, I think my remarks are going to be perhaps more practical, if that's the right word. I am a physicist, so I tend to be more practical. The One of the things that I've noticed in young faculty is when they go to teach a course for the first time, is that they study up on the content and they get ready for they bring examples, they go to the internet, they do research, they do an extraordinary amount of work. Young faculty tend to do that, and to get ready for this course. And they never ask, what is the purpose of this course? How does this course fit into a particular curriculum? How did this course come to existence? Why is this course taken now by students? These kinds of questions, I think, are often lacking. And what that can do, perhaps, is make the instructor completely unprepared for that class. Not in terms of the content, but in terms of the audience. So I think the first thing that one needs to do is to understand the place in the curriculum of that particular course. And I think you also need to understand that it is not a local event. The purpose of any particular course is not to graduate a person. That's going to happen over 4 years or 5 years, or however many years it takes. And what you need to think about, I think, is that this is a process, that you're part of the process in transforming a person in a way that whatever particular institution or particular local culture thinks one should do. And typically that is to turn out a person that's a critical thinker, I think. And along with the skills necessary to be successful in whatever arena they're going into. So I think that needs to happen. And I think you need to also understand the culture within your department. And the way you do that, there are sort of techniques you can do that: speak to the chair, understand the curriculum, these kinds of things that one can do. And then I think once you've sort of done that, situated the course in the trajectory of these young people's career at DePaul or wherever you are, then I think you need to start to think about less about teaching and more about student learning. So what exactly do I mean by that? Well, again, especially young faculty, what I see is they spend an awful lot of time getting prepared for a class. They present beautiful slides, perhaps scientific animations in my field. They do research. They do all of these kinds of things. They go out, they present a beautiful lecture for an hour and a half. They walk away thinking they've done a fantastic job, and perhaps they have. I'm sure they've done a fantastic job in terms of teaching. But typically, at least in the sciences, that hour and a half lecture never probed whether the student actually learned anything. And if you're not there, or at least I don't feel like I'm there, first of all, I'm not a very good orator, but I'm certainly not there to orate. What I'm hoping is to transform these students at the end of a lecture or at the end of a course or at the end of 4 years into a critical thinker. And sitting lecturing for an hour and a half is not, it never asks the questions whether the student learned. Okay? And so examples of what I mean by focusing on student learning. So in my department, luckily I'm in a department that is very focused on research-based, vetted pedagogy in which the student is engaged. So if many of you may not know, the physics community and the math community have led the charge in the sciences in exploring alternative student-centered, student-engaged curricula. These include things like, so I don't know how many of you are familiar with eye clickers, just-in-time teaching. All of these things were in fact developed by the physics community. So there's an entire sort of body that you can rely on or count on in terms of employing these strategies. Typically in my department, which is a department in which all the faculty are engaged in this kind of curriculum, lecture time now, sciences, if you don't know, tended to be it really was the model of the sort of fountain of knowledge at the front of the room, and then you sort of got sprayed with the water and picked up the knowledge. Typically in my department now, we're down to less than 50% of the hour and a half spent in the course time as lecturing. I'm typically down to as little as 0 to as much as maybe 25% lecturing. I've gone away entirely from the lecture. So what does that mean? How do you how do you model critical thinking for a student? How do you let them model critical thinking without this lecture, which is how you learn to be a critical thinker? This is a very difficult process because, again, most of us learn to be critical thinkers by having someone lecture to us, at least in part. Well, there's lots of ways you can do that. There's just-in-time teaching, which is a technique that was developed at the Air Force Academy in the physics department there, in which students, about an hour or so before your lecture, before you're actually, I'm calling it a lecture, what I mean is when the class meets, students send you typically 2 to 4 things that they did not understand about the reading. So, the other thing about student engagement is that students are responsible for the learning. You make the student responsible for their learning. And then you adapt your lecture based on the responses you got about an hour before the lecture, and it can be completely different. So you could have had, again, spent hours preparing a beautiful lecture on certain topics, and then when you read the responses from the students, see that, in fact, they're understanding what you spend all the time developing, and they're not understanding, excuse me, something else. And so then, this is why it's called just-in-time teaching. You have to adapt your teaching just in time for the lecture. It's not a lecture necessarily, but it's, we'll talk about what happens in the classroom in a minute, but it is a little bit challenging because it seems like you're gonna spend a lot of time doing this, but in fact, what I have found is that a topic that would have taken 20 minutes or 30 minutes of the class time, I can reduce now because none of the students have had any problems with it. So why go over material they already know? And instead focus on material or concepts that they're not understanding. And the only way you can know that, is if you engage, if the student becomes engaged in their own learning, because they have to feed you that information. There's no way that you can know that beforehand. So just-in-time teaching is something that we practice in our department. Just about everybody in our department practices that. It takes a little while to get used to because these beautiful lectures then get destroyed, but that's okay. The other kinds of things that we do is, of course, peer instruction. So peer instruction is not new. It's not revolutionary, but it does work. And so typically, for example, what in a physics lecture, physics class time, what I'll do is I'll come with the reading questions that people had, that is a concept that they didn't have. And I will actually take one of the questions from the emails that were sent to me. You can use this as a D2L and so forth. And they'll say, well, I didn't really understand conservation of energy. And so in the University of Colorado did a very interesting study in which students, for whatever reason, are hesitant to try things out, to sort of learn to be critical thinkers, if they have to put pen to paper. Something about that permanent process made students hesitate. So in our department, we bought these portable whiteboards. I call them portable whiteboards. They're yay big by yay big. And our classrooms are situated such that they can work together. So we hand out these portable whiteboards at the beginning of class time, along with markers and erasers. And then we have them work together, and they sort of will write stuff down, and they'll hold things up, and this is what we thought, and and then they'll have a whole discussion will start. And it is an incredible thing to watch happen, where before you could sort of use a Socratic type method where you pose questions and no one answered, as opposed to this method where they're actually engaged in writing down, engaged in answering the question, engaged in posing the question, and engaged in speaking with each other between groups as to what happened. That's not high tech, you know. It's a whiteboard with erasers, but it seems to have worked really well for us. Of course, eye clickers, where you engage the student by, so typically in the physics community, the way it works, we will put up a conceptual question up on the board or whatever. The class with the eye click, and you'll have a series of responses, and typically they're not numerical. So, you know, we're scientists, we usually deal with numbers. But the idea here is to probe the conceptual understanding. So we'll say something like, is event A greater than event B? Is it less than event B? Does event A happen before event B? These kinds of things. So there's not a lot of calculation at this point, but there is sort of thinking and understanding. Students then respond with the eye clickers, and you see instantly the response. So typically you'll have some sort of bell-shaped curve around one of the answers, A, B, C, D, and so forth. And then you have the students, and typically, almost always, at least in introductory courses, the answer is the wrong one, which is exactly what you want. You want accuracy that because if it's the right one, there's not a lot of room for engagement and that conversation. And so then you have them discuss with each other the question that was posed. You haven't said a thing. All you've done is pose the question up there and looked at the responses. And so then they engage in a conversation, and after about 3 or 4 minutes, you pose the question again, and almost inevitably you'll see the answer, the Gaussian, move over to the correct answer, as students have learned, and then you engage in a conversation as to why people changed their mind. Why, for example, did they come up with the first answer? And what was it in the conversation that caused them to change the second answer? So there is almost no lecture going on here. It's all sort of a conversation between students and a peer instruction that goes on. There's a lot of techniques specific techniques that we employ, again, coming from the physics education community. And I think that's where I would like to sort of conclude my remarks. My time is about up. But there is a wealth of material out there. In my field, it's the physics education community. Physics programs across the country now are giving PhDs in physics education research. That is, you pass the regular physics curriculum exams and so forth. But then your research is actually in physics education. So you get a PhD in physics with a specialty in education research. And there's a wealth of material that I think is translatable, that is scalable, away from physics to other disciplines. We've used it in our department. We are now moving to what's called studio physics. If you want to talk about these things, it's even a more engaged curriculum. So I think with that, I'll stop my...
Thank you, Jesus. Our final speaker is Amber Settle. Amber is an associate professor in the School of Computing in the College of Computing and Digital Media and has been a full-time faculty member at DePaul since 1996. She earned a BS in mathematics and a BA in German from the University of Arizona and an MS and PhD in computer science from the University of Chicago. Dr. Settle's research interests include information technology and computer science education and theoretical computer science. She served as the founding director of the Innovation in Technology Education Center from 2008 until 2011, and has served on the advisory board for the ACM Special Interest Group for Computer Science Education since 2010. Please give her a round of applause.
Okay, so I'm in technology, so I'm like the worst of all of the things that you have. I can't do it without my PowerPoint. The other thing is I absolutely cannot stand still and sit in a spot. They threatened to like strap me in, and I said it wasn't going to happen. So thank you for letting me speak here. You've heard a little bit about me, but let me give you a little bit of context. I think I'm actually going to be both bringing together some of the stuff that all of the other speakers have talked about, but also talking about some things that are new. So as I said, I'm in the School of Computing. There's a sister school, which is Cinema Interactive Media, and I've been here since 1996. I teach a lot of technical classes, so a lot of programming classes, web development. I'm a theoretician by training, so of course I do a lot of those classes, but I've also had a chance to do a Discover Chicago class on the digital divide. So I have actually had a chance to teach a little bit in the liberal studies program too. And so all of this is going to inform the stuff that I'm going to talk about, but hopefully the things I'm going to talk about are not going to be things that are going to be particular to computer science classes, but also things that you'll be able to use in your classes. I'm going to focus first on creative thinking. I think that we've heard a lot about critical thinking, and I want to focus more on creative thinking, the reason being that a lot of people who go into computer science don't think about it as a creative field. And I think that's a mistake. I think it's a huge mistake, because computer science is actually very, very creative. And so there's 3 things that I really try to do when I'm teaching those introductory development classes to help students understand that they need to be creative, and that's actually an important part of the process when you're looking at technology. And so those are the 3 I'm going to talk about. I think the first is, a lot of times people won't be creative because they're afraid. They're afraid of making mistakes. And so if you can destigmatize mistakes, if you can let them know that there's nothing wrong with making a mistake, that in fact you learn more from mistakes, that can put them in a really good position for being more creative in the classroom, because they'll be less afraid to be creative. So I start by telling them, of course, that no one is perfect, and illustrate that very well by being very imperfect myself. So as you heard, my undergraduate degree is in mathematics. My PhD was in theoretical computer science. I proved a bunch of theorems for my thesis. But I cannot for the life of me do basic arithmetic. I don't know what it is, but trying to multiply even single-digit numbers, I oftentimes will get wrong. And so a lot of the examples that you'll have in beginning programming classes are kind of basic arithmetic things. You know, you're multiplying things, you're dividing, you're doing modulus, you're doing primes, you know, whatever it is that you're doing for these beginning things. And I like the classroom to be really interactive, and so I'll ask them, so what's the answer to this? What should we see when we run this program? And I really say, no, guys, my arithmetic's really poor here. I'm not kidding. You have to help me out. This is something that I really need your participation. Because if they're feeling like you're just asking the question to get them to answer, I think that they're less willing to do that. But if they can genuinely see that I really suck at arithmetic, that they're much more likely to actually want to participate in that process. And then they also see that I make mistakes, and that therefore it's fine when they do too, right? If I'm not going to be perfect, it's actually okay for them. There was a really fun interaction that I had with a student about a year ago. He came into my office and he'd written a bunch of code, and all of it was really poorly structured and wasn't answering the question. And so I said, well, you need to put this aside, you need to put that aside, you need to take this new idea. And he got really frustrated. And he said, I spent all of this time writing this code that's so bad. And I said, great. I'm really glad to hear you say that, because there's so much bad code that you're going to write as a programmer in your life that it's good to get it out of your system now. You know, I mean, do it now, and then you will know what you're not supposed to do later. And I think that, you know, the key there, and he was stunned. It's like I slapped him. I mean, to say, you know, I'm so happy that you're writing bad code. I don't think that he'd ever thought that I was going to say that. I think it was kind of, oh, there, it'll get better. But, you know, you really learn a lot more from the mistakes that you make than you do from somebody telling you something. So I can tell them until I'm blue in the face, you're going to make this mistake, and you're going to make that mistake. But until they actually make that mistake, they're not going to remember. So it's really important for them to see that mistakes are actually part of the learning process, and so they shouldn't take that as a problem. That's actually something that's a positive. And of course, the way that I encourage this is, you know, if we're talking about particulars, is to make sure that I'm very generous with partial credit. I would rather actually see something written down, even something that has mistakes in it, than not see anything at all. And so you need to make sure that you enforce that, right? Mistakes are part of the process. Okay. The other thing is when you go into, and of course my training is in mathematics, and so I think in math, but also in computer science, the textbooks, if you look at them, they have, you know, here's this beautiful algorithm, and then here's this beautiful piece of code that implements this algorithm perfectly. And isn't that fabulous? Let's look and see what it does on a few examples. And they don't see that this is actually a process. These solutions don't spring from someone's head, just, you know, whole and jump onto the page and that's it. That it's actually something that has to be developed over time. And so I think it's really important to let them see that, to let them see that the first solution you're going to come up with is going to be a bad one. And then part of what you're going to figure out is why is it bad and what do you want to do differently with that. So what I do in particular is when I'm teaching beginning programming classes, I will actually develop code in front of the students. We'll start from scratch and we'll develop a little piece of it and then we'll critique it. What's wrong with this piece of code? What could we do better? What else do we want to do? Did I not state something in the problem? Are we actually missing something in the problem description? So let's go back and modify the problem description so that they can see that this is something that happens iteratively, right? This is something that happens over time and actually gets changed. And a partial solution is better than none at all, right? If we can come up with some partial solution, that lets us see understand the problem better. It lets us see what we're doing. It lets us try to innovate a little bit with that solution. And then I think this is really important. When they're making mistakes, they're going to feel bad about themselves. So you need to make sure that you stay as positive as possible about this. So if they give you a really odd, really weird solution to something, I think it's important to try to find what is beneficial in that. And it is really beneficial because sometimes people have really interesting ways of solving problems, and those interesting ways can be really helpful in terms of discussing why a solution is different or better than another. And so you can talk about that, but you can't talk about that if the only solutions you're seeing are the ones that you had thought of and prescribed. So I think it's actually really good to have them actually come up with some solutions. And it's also important to highlight achievable characteristics, right? You can see this in pedagogy for kids, right? Don't tell them they're smart, tell them they work hard. I think it's the same kind of thing here. You want to let them know, I tell them, for example, you know, a big part of being a successful programmer is just being really stubborn. I'm going to figure this problem out, and maybe I'll spend 6 hours doing it, but I will figure this problem out. That's a really important characteristic. But don't do that on your assignment. You need to contact me first, right? So I mean, you want to talk about that process, that being stubborn, that's important, and also that experimentation is important. You know, you did test your code. I don't know, did you run it? Did you test it? Is it doing what you think it's supposed to be doing? So they need to actually get out there and experiment with it to try to be a little bit creative. Okay, critical thinking. We've definitely talked about a lot of these, and so I'm going to be talking about some of the things we've done before. But people who come into STEM fields, science, technology, engineering, math, I think a lot of times are looking for the right answer. There's a right answer. I know it is. I just have to find it. And so what you have to do is tell them that there actually is no such thing as a right answer in a lot of contexts. I mean, if you're multiplying 2 times 2, yes, but you know, not if you change the arithmetic field, right? Okay, in any case, there is usually not a right answer to things. That a lot of it depends on what the assumptions that you're making are about your problem or about what kind of a solution you're looking for. You know, what are you trying to maximize over? That really makes a big difference in what you're trying to do. So context actually makes a huge difference. And I actually want them to start this process of questioning authority with me. So I want them to ask me, why are we doing this? Why is this problem important? What does this have to do with what we're trying to do in the classroom? I really want them to ask me questions. And if I can't justify it to them, I need to get back to them because I really need to have an answer for why it is that we are trying to do something. And it's also really important, and I love this story because I have an 8-year-old daughter, and she's already online a ton. She's a huge Minecraft fan. She loves going out to Minecraft and playing in Minecraft. And she, for a very long time, had this tendency of, if it's on the internet, it's true. And she's 8, so you can kind of forgive that. But I've actually seen that in a lot of my students, right? They're 18, that's a little less forgivable. And so what I really like is I had this opportunity with her of illustrating problems with the things you can read online. So Wikipedia, of course, is great because we've crowdsourced a lot of, you know, trying to understand things. You can pull a lot of information in from a lot of different people. You can end up with some things that are great. But you can also end up manipulating that. And so there was this great thing that happened. We were watching the Olympics. I'm a huge Olympics fan. We were watching the Olympics this summer, and I was cheering for some New Zealand teams. And she was a little puzzled as to why I was cheering for New Zealand teams. And I said, well, I know some people in New Zealand. You remember, there was a person I had met at a conference that I told her about. You remember Paul? He's from New Zealand. Oh, yeah, she said. Okay, so a few days later, she was cheering for New Zealand team. And I said, oh, so, you know, why are you cheering for New Zealand? Well, that's where Paul's from, she said. And I said, oh, okay, great. So I had to email Paul and tell him about this. And he thought this was incredibly amusing. And so he sent me the following image. It had to be an image, of course, because by the time he changed it, it had actually gotten fixed. But if you read that beginning line, New Zealand is where Paul is from, Aaron said so. So, you know, this was, I mean, first of all, incredibly sweet that he went to the trouble of going out to the page, the Wikipedia page for New Zealand, and modifying it so that it actually referenced Erin. She was very excited about that. But it also gave me a chance to talk about the fact that Wikipedia can be modified this way, and that, yeah, it gets corrected, hence the reason Paula had to send me an image of this as opposed to sending me a link. But that, you know, it is actually something that people can go and modify. And this is something I think that our students know about if they know anything about Stephen Colbert, because he's famous for doing this, right? For asking his fans to go out there and modify Wikipedia and change, you know, change the truth, because his truthiness is the big thing that he tries to get done. And so that's a more mature example that you can talk about with students, but I think it's really important for them to understand that, you know, just because it's on the internet, just because your teacher says so, just because, you know, that's not necessarily the case, right? So being critical, I think, is sometimes realizing that kind of thing. Okay. Presenting multiple viewpoints, a lot of people have already talked about this, but I want to say, for example, that this is really important in technology, and this is something that a lot of times you don't see. Technologists, for the most part, are male and white. And so they are not thinking from the perspective of other people, and that means that they're not developing technology that will necessarily be useful for those other populations. And so you need to make sure that they understand that thinking outside of themselves is important when you're talking about technology too. And so, you know, user interfaces that work for the colorblind, or, you know, technology that's been developed for populations that aren't ones that are represented in technology is something that's really important. And you can do that in a really technical way in your classes. So I think that's an important thing to talk about. And then what I really like is emphasizing debate. So our first speaker actually talked a little bit about debate, but I think that debate actually has a really strong place in technology, because there are ethical questions as well as technological questions that can be debated. One of my favorites is to have the students actually debate some controversial thing in technology. My favorite is music downloads. So they all do it, right? But you have to try to get them to say, you know, try to justify, for example, why it would be that we would not want to have this kind of thing happen. And that's really an intersection between social stuff and technology, but technology is very informed by social context. And so I think it's really important, even in an area like computer science, that you think about a lot of this stuff. And my inspiration for this, of course, which is the last thing I'll say, is my mother. Because when I was growing up, she often told my brother and I that if we felt she was wrong about something, that all we had to do was try to convince her that she was wrong and she would change her mind. And I'm very proud that she actually did do that sometimes. So I think it's really important to emphasize to them, look, if you can change my mind about me being wrong about something, then by all means. That means I couldn't hold a defensible position. So that means that you were, in fact, right. So I think it's really important there. Okay, so that is actually, I believe my time is up now. So thank you.
Thank you all for presenting such interesting processes and perspectives from different contexts. And we do have a little bit of time. I think what I'm going to do is just let you guys address your questions to the speakers. And then at some point, Rena will come back in and get us on track. So thank you again.
So that's a really good question, and that's why I started my remarks trying to emphasize the culture in the department, because if you're doing it in isolation, if you're the only one doing this, and the students have, and the correct, I want to say, the optimal behavior hasn't been modeled for the students, or they haven't had a chance to model it, then you're likely to run into that more often. Again, in our department, everybody does it. So the students come in expecting that. They, for one thing, as you're well aware, science students, or maybe I should say physics students, don't read textbooks. I don't know why. But this is actually, and these textbooks are actually brilliantly written, most of them. They're really well written. There's a wealth of material, and they're really a good reference. And so this technique actually gets them to read the book for a change. Because I don't know what it is about science students not reading textbooks. But it is going to happen. It does happen. And I mean, I think you have to sort of understand that it's a process, and that if they have not had a chance to, if they haven't had that modeled for them, or they haven't had a chance to model that for themselves, that is the critical reading skills, and how to sort of analyze the reading to come up with what's really important that they didn't understand, it's going to take you a little while to happen. It does happen, yes. It gets better at the, actually, it starts off bad, gets better in the middle, and then everybody's tired at the end. And then at the end, you're getting, I didn't understand chapter 3 or whatever it might be. Yes. Is there a number, so that it comes out to them really being understand all the material and how to come up with questions? If they really understand all the material, they shouldn't be in the course. I mean, why? I don't. I mean, then that's fine. I mean, the point again is not for me to be a good teacher; it's for them to learn. If they really understood the material, good for them. No, I see, but you're saying that the point of this is for them to tell you what they don't understand. So right. Put that in a lecture, but somebody feels compelled to just come up with questions, even though they understood at least that. Yeah. Oh yeah, I get questions from all over that have nothing to do with the material, and that's that's great. And this just-in-time teaching actually. Most of us now in the department also do just-in-time lecturing. While you're in the class, you'll actually adapt as you know. So this requires constant feedback. So you're constantly getting the feedback from the students. And if you're in the class, you may have to abandon even what you had just changed because the class has gone in a different direction. They've picked up the material, or they haven't understood something. And then you simply abandon what you were doing and address what they are not getting. But yes, I get questions from all that don't have to do with the reading, and that's great.
I have a follow-up question to that. So if we focus on sciences, then we can see that students in Singapore or in Korea, they usually do much better than students here for some reason. And then maybe they don't have as good, maybe their textbooks are not as good, and maybe the process is not as open and democratic, maybe the discussions are not as open. So my question is, are we doing something wrong, or maybe do we babysit the students too much, or is there a lesson that we can learn from that?
So I'm going to let me just say, I don't know what goes on in Singapore, so I can't really address that. My suspicion is that there's a lot of tracking that's going on, and I'm not sure that the exams are really comparing apples to apples. So, but I don't know what goes on in Singapore. If their students are being successful, good for them. They should continue doing what they're doing. I don't know if anyone.
Well, I mean, I can talk a little bit about computing. In the U.S., there is absolutely no requirement that you take computing ever. So students just don't learn computer science. So that other countries would do better at computer science wouldn't be surprising to me, given that it doesn't count as a science, it doesn't count as a math, and if it doesn't count as one of those things, it's not going to count as anything. Now, this is something that the ACM, the Association for Computing Machinery, is working on changing, because never having a student having seen any sort of computing before they get to the college level, particularly in modern society, is not really a recipe for success. And so, it's definitely trying to be changed. But I think what you have to look at is what's valued in a particular culture, what's valued in a particular society, and then how does that get rewarded? And that is a big part of how these things happen. So, if science is very rewarded in a particular culture, then that's going to be something that the students are going to see as being very valuable and then try to do.
How do you three deal with the demand of assessment for very specific rubrics, which I think drive out creativity and critical thinking? So can you comment on that, please?
And when you're talking about assessments, are you talking about our own assessment of our own ability to meet learning outcomes, or assessments in terms that we might create a rubric to evaluate student learning?
That's it.
Yeah. You know, I don't know that I have a good answer to that question. I think probably like you, I'm not a huge fan of the rubric. In the context of my work, I really rarely have exams in class. It's mostly papers. And so I do have several colleagues who like the rubric for many reasons, not the least of which it sort of eases their grading, right? And all their comments. And for me, I do feel like I spend my life grading, but what I prefer is to provide copious comments on papers instead of, so I think in my mind I might have maybe a conceptual rubric, and I really, actually as a department, we have been very intentional over the last 2 years in creating very clear guidelines and expectations about student writing at the 100, 200, and 300 level undergraduate, and at the graduate level, sort of what kind of writing capabilities we would expect of different level students and in different classes. So I think it speaks a little bit to what you were saying, Jesus, about creating sort of kind of that gestalt, a whole across the curriculum within a department. But what I tend to do instead of that rubric, even though a rubric might be guiding me, is provide really copious comments on papers, writing the paper, you know, sort of about whatever. This wasn't articulated clearly, or this paragraph would have been much better placed up here because there's redundance, or the argument loses its logical flow. That kind of thing, for me, I suspect, like you, or both in whatever context, is probably a little bit more useful than a really structured rubric.
Well, I actually have colleagues who teach computer game development. And computer game development, I think, is very creative. They use rubrics. And I think the reason that they're able to use rubrics and have that work is that a rubric, I think, to me, isn't necessarily about making your grading easier. It's about communicating your expectations to the students. And so if you've come up with a rubric that represents the kind of things that you want to see in that assessment and represents all of them, then it's a way of saying, here's what I value, and here's what I'm going to grade you on, and here's what percentage or whatever amount that thing is going to count for. So now that's hard. It's really hard, I think, to come up with a good rubric. But I know I have colleagues who teach, you know, animation, who teach game development, you know, very creative fields that are nevertheless technical, that use rubrics and use them really well. And it guides the students, they say.
So that's a really important question, and I can't minimize the importance of that for junior faculty, that you do need to sort of watch for those kinds of things. After I was tenured. And it wasn't so much because of the tenure process, because I was worried about student evaluations hurting my chances for tenure, but there's so many things you have to do. You have to get your, first of all, you have to learn what it's like to be at a university, what it is to be faculty. You have to continue your scholarship. You have to, you know, all of these kinds of things. It just, I don't know whether there's room for much exploration there. I think you really have to understand your department culture. I mean, I think you have to, you know, understand that culture and understand that you're living within that culture. In physics, we would say you're solving a partial differential equation with these boundary conditions. And the boundary conditions are your local culture. Now, clearly you can affect culture. And maybe with having conversations, getting together with other young faculty, getting together with senior faculty who are interested in trying new pedagogies, you can affect the culture of your department if it's not a culture now that appreciates the kinds of things we're talking about here. But one has to pay attention to it. You can't ignore it, I think.